These questions are increasingly easy to get wrong. If you don't believe it, give it a try. Let's start by saying the result of the first one is 3. The second one is 3. The third one is 3. What is the absolute value of x for the fourth one? What is the fifth one equal to x? And what is the sixth one equal to negative x? Okay, let's briefly discuss the first 3 and focus more on the last 3. Additionally, let me mention that every day we cover middle school content in the live stream. If you haven't followed me yet, make sure to do so. And don't forget to tap the little heart to avoid losing track of me in the future. Now the first one, the square of 3 is 9, and the square root of 9. Isn't that just the arithmetic square root of 9? That's 3, no need to say more. The second one, the square of the square root of 3 is equivalent to the square root of 3 times the square root of 3, which is also 3. The third one, the square of negative square root of 3 is equivalent to negative square root of 3 times negative square root of 3, which is still 3, no need to say more, right? Now for the fourth one, why do we need to add an absolute value here? Can we do without it? No. We must add the absolute value to ensure that the final result cannot be a negative number. Because here, you don't know whether x is positive or negative. Can x be a complex number here? Yes, x squared is not a complex number, but x could be a complex number, right? So, to ensure that the final result is not complex, we must add an absolute value to x. If you don't add the absolute value, x could be negative. Do you understand this reasoning? Now, why don't we add an absolute value to the next one? Because you see, the radicand of the square root here is x. So it is inherently stipulated that it cannot be negative, right? X cannot be negative here. Therefore, you don't need to add an absolute value to ensure its non-negativity. You don't need to add an absolute value here because the negative x is the radicand of the quadratic expression, and it cannot be negative by itself. Notice that although it's negative x, it's not a negative number. It's not that all numbers with a negative sign are negative numbers. Don't get confused. Hey, the negative x here is actually not a negative number, so negative x doesn't need an absolute value. Got it?